Today's lesson, it will be on circles and arcs. Our objective is to find the measures of central angles and arcs. The next video will be circumference and arc length. So a circle is a set of all points equal distance from a given point called the center. You can name a circle by its center. So circle P down below can be named circle P. You have a diameter of a circle, which contains the center of a circle and has both endpoints on a circle. You have a radius is a segment that has one endpoint on the circle and at the center of a circle. And then you have congruent circles have congruent radii. And then you have a central angle is an angle whose vertex is the center of the circle. And I have everything labeled here where diameter, radius, central angle, and center of a circle. The only thing new here, probably for some of you students, is the central angle. So remember that the central angle is where the vertex is the center of a circle. Therefore, the central angle is also formed by two radii. And we're going to use these rules to find major, minor arcs, semicircles, and arc measure. So you can find the length of a part of a circle's circumference by relating it to an angle in the circle. So you have a minor arc, okay? So you have a minor arc of a circle, which is going to be greater than 0, but less than 180 degrees. You're also going to have a major arc, which is between 180 and 360. And then you have the semicircle, which is exactly 180 degrees. And then you have a circle, which is exactly 360 degrees. So in the diagram here, I have STR is a major arc, RS is a minor arc. So with minor arcs, you're going to name with 2 letters. Major arcs, you're going to use 3 letters. Let's fix this. So 3 letters for major arc. Why for 3 letters? Because that middle letter in a major arc is direction. So with arc STR in the example above, S is where you start, R is where you end, and T is the direction you head. Semicircle, you can use 2 or 3 letters, and a circle is obviously named by the center of the circle. So we need to be able to recognize minor arcs, semicircles, and major arcs. So the minor arcs of circle O. So minor arcs are between 0 and 180 degrees. So they're less than half a circle, but greater than a circle, or greater than 0. So I know I have arc AC, I have arc AD, I have arc CE, and I have arc DE. Okay, those are all the minor arcs because they're less than 180 degrees. They're less than half a circle. Now, if I rename them as CA, DA, CE, and ED, those are the same arcs. Then you have semicircles. Okay, we have semicircle AE. Okay, arc AE is a semicircle. We also have arc DC is a semicircle. We could also name a specific semicircle by using 3 letters. So I can do semicircle DAC. I can do DEC. So these 2 arcs are semicircles, but they're different semicircles. Even though they start and end in the same spot, again, the middle letter indicates direction. And then we can do semicircles again. We have semicircle ACE, and we also have semicircle ADE. So different ways to name semicircles. You can use 2 letters for the generic semicircle, Doesn't matter what direction you go in. If you want to be more specific, use 3 letters for semicircle so you indicate which half of the circle you're talking about. Then you have major arcs of circle O that contain point A. So major arcs are greater than 180 degrees but less than 360. So a major arc that will contain point A, meaning that the arc will sweep through A. So I have arc DAE. I also have arc EAC. So again, D to A to E. So we have this arc right here. It's greater than 180 degrees. So there's the DAE. And then in red, I'll show you the EAC, E to A to C. So I can tell you that right there, those are 2 major arcs that contain point A. And we can do the bottom example too. I'll just name a few. I'm not going to name them all. The minor arcs of A. I have arc SP. I also have PQ. I have arc QR and SR. Those are all minor arcs. Semicircles, I'm going to use generic here. So semicircle, we have RP because it's the diameter. If I want to be more specific, I could do RSP or I could do RQP. Those are more specific. And then major arcs that contain point Q. So I want anything greater than a half circle but less than a full circle that contain point Q. So I can have RSQ. RSQ is major that contain point Q. And then I also have PSQ. Okay, those are major arcs that contain point Q. So after naming your major, minor arcs, and semicircles, you should also be able to find the arc measure. The arc measure is the degree measurement between the 2 points on the circle. Okay, so in my example, I have circle S, and the red line or the red arc is RT. So if I look at R and T, what's the degree measurement between RT? I'm not asking for the length of RT. I want the arc measurement, which is how many degrees does it take to go from R to T from the center of the circle? Well, it's 50 degrees. You should also notice that angle S is a central angle. So you have to know that a central angle is going to be congruent to an arc measure, and these are in degrees, the units. So if arc RT is 50 degrees, arc TQR is 310 because there's 360 degrees in a circle. You can also use arc addition. So down here is arc addition. If you have 2 adjacent arcs that share a point on the circle, they're called adjacent arcs. So I have arc AB plus arc BC. So they're adjacent because they share they share point B. If you add them together, you get the arc of ABC. So example, if this was 30 degrees and this was 100 degrees, okay, then I know that the measure of 30 plus 100, this would be 130. And we're going to get to examples to solve for arc measurement. So let's find the arc measures of BC. So I have BC, the central angle is 32, so the arc measure of BC is 32 degrees. I have BD, well, if BC is 32, BD is going to be BC plus CD, so those are adjacent arcs, which is 32 plus 58, which is 90. So BD arc measure is 90. So if this is 58, this is 58. Okay, remember that CA is a diameter, so I know that COD and DOA are linear pairs. So I know that DOA central angle. Okay, so I do 180 minus 58 is 122. So I know that this is 122. And I know that this is 148 because those are linear pairs. Now I can find everything from A to B to C is 180 degrees because it's a semicircle. So again, A to B to C is 180. A to B is 148. So how did I get that? I knew that ABC is 180, 180 minus 32. So this was equal to 180 minus 32. Let's go to the last example here. I want the measure of PR. PR arc is the same as its central angle, so it's 77. R to S, so notice that PS is diameter, so this is 103. So R to S is 103. PRQ, P to R to Q is going to be arc addition, so 77 plus 103 plus 28. So I have 77 plus 103 plus 28, which is 208. And then I have P to Q to R. So from P to Q to R, okay, I know the whole thing is 360. So this is going to be 360 minus 77. So 360 minus 7 is 283. And that's how you find arc measures using central angles of a circle, because you remember the central angle is equal to its arc measure. If you have any questions about arc measures, major and minor arcs or semicircles, please send me a message.